right, so get ready because we are going to take a deep dive into the world of snowflakes.
Oh, this will be fun.
You guys sent in a ton of articles and research on this.
A lot of interest.
Yeah. And it seems like you are fascinated by everything from how they form to the math behind them.
Oh, yeah, and the history, too, right?
Definitely some history in there, for sure.
Oh.
So I guess let's start with, like, the super basic question.
Okay.
What even is a snowflake?
Yeah.
And, like, how does it even form?
Yeah.
I know it's not just a frozen raindrop, right?
Right, that's hail.
Yeah.
Exactly.
Yeah.
Hail forms when you have like super cooled water droplets and they freeze onto some kind of nucleus but a snowflake. It's a little bit more magical, you know? They form when water vapor in the atmosphere, it kind of bypasses that whole liquid stage and goes straight from vapor to ice.
Oh, wow.
And that creates those really crazy shapes we see.
So they just skip the whole raindrop phase.
Exactly, precisely.
Wow.
And so as these little tiny ice crystals are fallen through the atmosphere, they encounter all these different like temperatures and humidity levels.
Right.
And these kind of changing conditions cause more water molecules to freeze onto the crystal. And it just adds and adds and adds to the structure.
So that's how they get so complex.
It's how they get so complex, exactly.
So I've heard that, like, no two snowflakes are alike.
Right.
Is that actually true?
That's a claim that has captivated people, like, forever.
Really?
And the science says, yeah, it's probably right, because the atmospheric conditions each snowflake runs into is so varied.
Yeah.
The chances of two of them forming in exactly the same way.
Yeah.
Incredibly slim.
So each snowflake is like a little unique fingerprint.
Yeah, like a tiny little fingerprint falling from the sky.
That's incredible.
It's pretty remarkable.
And it's been intriguing people for a long time.
Oh, yeah, for a really long time. I mean, we have records back to, like, Johannes Kepler, and Descartes, marveling at the symmetrical beauty of snowflakes.
Didn't Robert Hooke make some of the first drawings of snowflakes?
He did.
I think he was in, like, the 17th century or something.
Yeah, he was, like, this polymath, right?
Yeah.
And he's using a microscope. And he was able to capture those intricate structures and drawings, and they were remarkably accurate.
Wow.
For the time.
And that helped propel further scientific study.
Oh, absolutely, yeah.
So, I mean, eventually someone had to take the first photograph of a snowflake.
They did.
So who was that?
That was Wilson Owen Bentley, a farmer from Vermont.
Wait, a farmer?
Yeah, he was totally captivated by them. He was captivated by the science and the beauty. He saw them as these, like, tiny miracles of nature.
Wow.
And he spent years perfecting his technique.
Right.
He combined a camera with a microscope to capture those intricate details.
Wow.
And his dedication, it paid off because he ended up taking over 5,000 photographs of snowflakes over his lifetime, yeah.
That's amazing.
It is.
I bet his work really helped pave the way for more in-depth study.
Oh, it did, yeah.
And his photos gave scientists so many valuable insights.
Yeah, to the variety and complexity of the forms, yeah.
But it wasn't really until the 20th century that the study of snowflakes really took off.
Yeah, it really wasn't until the 20th century.
And a lot of that is thanks to Yukichiro Nakaya, right?
Yes.
The Snowflake Man.
Yeah, the Snowflake Man.
He was amazing.
He was a Japanese physicist, and he dedicated his whole life to understanding snowflakes.
So he went beyond just observation.
He went way beyond observation.
Wow.
He actually created artificial snowflakes.
Oh, wow.
In his lab.
That's incredible.
Yeah, he controlled the temperature and the humidity just to unlock those secrets of how they form.
I read that he even, like, created a whole classification system.
He did.
And his book is like a foundational text.
It is. Snow crystals. Natural and artificial.
I saw a copy for sale online for almost $4,500.
Yeah. Well, that's a testament to the impact of his work. But, you know, his work goes way beyond just a hefty price tag.
Yeah.
He really advanced our understanding of how snowflakes form. And his research still influences scientists today.
Wow, and there's even a museum in Japan dedicated to him.
There is.
Wow, a whole museum for snowflakes.
Yeah.
That's amazing.
I mean, it speaks volumes about the fascination these things hold for scientists and the public.
For everyone.
Yeah, and today, researchers, you know, people like Kenneth Librecht
are
continuing to build upon Nakaya's legacy.
Yeah.
Using, you know, cutting-edge technology to capture even greater detail.
Wait, Kenneth Librecht, didn't he work on that movie Frozen?
He did.
He was like their snowflake consultant.
Here it was.
I can't believe that's a real job.
I know, right?
It's amazing.
But his expertise isn't just limited to the science.
Oh.
He actually helped Disney design the snowflakes for the movie.
Wow.
Bringing the beauty and the magic of snowflakes to the big screen.
That's so cool.
It's a pretty cool job, right?
It's amazing. And you were saying if people want to see more of his work?
Yeah, if you want to see like the level of detail he can capture,
Uh-huh.
you can check out his website. It's called Snow Crystals.
Okay.
And the photography there is just breathtaking.
So it sounds like snowflakes aren't just science.
No, they're not.
They're art. They're magic.
It's kind of magic. Yeah,
It's like their own art form.
they are.
And they've inspired artists and poets for centuries.
Absolutely, for centuries.
Yeah.
They're just a reminder that even in like the depths of winter,
Mm-hmm.
there's still this delicate beauty to be found.
Yeah, so we've talked about how snowflakes form, and we've talked about the history of their study.
Right.
But what about math?
Oh, yeah,
I mean, snowflakes are so symmetrical.
they are.
There are all these patterns.
There are.
So there must be some connection there.
You're picking up on something. Yeah, they hold a special place in mathematics,
Like,
particularly geometry and the concept of infinity.
oh, okay, I'm very intrigued.
Yeah.
So tell me more about the connection between snowflakes and math.
Okay, well, there's this Swedish mathematician named Helge von Koch,
Okay.
and he designed this fascinating shape.
Uh-huh.
It's called the Koch snowflake.
Hooke snowflake.
Yeah.
What is that?
So imagine you start with just a simple equilateral triangle, right?
Okay, a triangle.
Yeah, and you divide each side into 3 equal segments.
Okay.
And then you remove that middle segment
Okay.
on each side,
Wow.
and you replace it with 2 more line segments
Okay.
that form a smaller equilateral triangle.
So it's like
Right.
pointing outward.
It's like a star, kind of.
Yeah, kind of like a star. And then you repeat that process over and over again
Oh, wow.
on each new edge.
So you're adding all these little triangles.
You just keep adding smaller and smaller triangles.
It seems like it would just grow forever.
In a way, it does.
Uh-huh.
Yeah, so each time you do that,
Mm-hmm.
the perimeter of the snowflake, it gets longer and longer
Right.
because you're adding more sides.
Mm.
Right.
Yeah.
But here's the paradox.
Okay.
Even though the perimeter keeps growing infinitely,
Uh-huh.
the area of the snowflake stays finite.
It would.
It never goes beyond a certain limit.
Wow, how is that even possible?
I know, it's crazy.
That's amazing.
Right.
Infinite perimeter,
Infinite perimeter.
but a finite area.
Finite area.
So how does that...
It's wild. It's a really good example of how math can be used to, like, represent these impossible concepts.
Right.
And it kind of ties back to the snowflake structure.
Okay.
Because if you look at a snowflake under a microscope,
Yeah.
you see that branching pattern, right, repeating itself at smaller and smaller scales.
Oh, I see.
Kind of like those iterations of the Hooke snowflake.
So, like, even though every snowflake is unique,
Right.
there's still this mathematical order to it.
Yeah, like an underlying mathematical order.
That's so cool.
It is, and that order isn't just like in their shape. Right.
Okay.
Researchers have figured out that even the way they move
Oh, really?
as they fall follows like these predictable patterns.
I always thought they just kind of like floated down randomly.
It looks random, like to us,
Yeah.
right, with the naked eye.
Yeah.
But scientists started modeling the movement
Yeah.
using something called a Lagrangian particle model.
What? A Lagrange.
Lagrangian particle model.
Oh, man, I don't even know what that means.
It's a little technical,
Yeah.
but basically they're tracking individual snowflakes
Okay.
as they fall.
So, like, zooming in on one snowflake.
Exactly.
Perfect.
And watching its journey.
Wow.
And they study how it interacts with the air, how that affects its movement.
So they can track, like, its whole path.
Yeah, the whole path.
That's amazing.
And what's crazy is, that they found that, like, despite their unique shapes,
Yeah.
snowflakes actually accelerate
Right.
according to a pattern.
Wow.
There's this mathematical relationship.
So it's not random.
It's not random.
It's not random, so they speed up in a predictable way as they fall.
So every snowflake, like, even though they're all unique.
Uh-huh. They still kind of follow this universal law.
That's so cool.
It's pretty cool. It suggests that there's more to snowflakes than we might think.
Yeah.
They, like, embody randomness and order,
Yeah.
complexity and simplicity.
Yeah,
like
tiny puzzles.
it's like this perfect balance. Yeah.
They're like little puzzles that just keep revealing these secrets.
So you mentioned before NASA's Global Snowflake Network.
Oh, yeah.
I remember reading about that.
Yeah, if, like, regular people can contribute to research,
Yeah.
imagine what dedicated scientists are finding out.
What are they discovering?
Well, one interesting thing is that the density of a snowflake,
Okay.
it really affects how it, interacts with air currents.
Oh.
So lighter, fluffier ones,
Yeah.
they get tossed around more by turbulent eddies,
Makes sense.
while denser snowflakes tend to fall more straight down.
Oh, so the shape and density.
It all matters, yeah. They affect, its whole journey.
Yeah, from the moment it forms to when it hits the ground.
That's really cool. And this research isn't just, fun facts, right?
No, it's not just for fun.
It has, real-world implications.
Yeah, absolutely.
Like what?
So understanding how individual snowflakes, behave,
Yeah.
it helps us predict, bigger things,
Okay.
like snowpack formation
Uh-huh.
and melt rates.
Okay.
And that stuff's important for, managing water resources
Right.
or forecasting avalanches,
Oh, wow.
even climate modeling.
So, a tiny snowflake
Snowflake.
can have a huge impact
A ripple effect.
on all these things.
All sorts of things.
That's amazing. It's like what we were talking about before,
right.
about the magic of snowflakes.
Yeah, it's not just about, how they look.
Uh-huh.
It's the way they connect to these bigger systems and patterns.
You know what I've always been curious about?
What's that?
After a fresh snowfall,
Yeah.
everything gets so quiet. Is there a reason for that?
There is.
Okay.
Snow is a natural sound absorber.
Hmm.
So all those tiny ice crystals with all the little air pockets between them,
Uh-huh.
they're like these little sound traps.
Oh, wow.
And they're really good at absorbing high-frequency sounds,
I see.
which is why it sounds so quiet.
So it's like nature hit the mute button.
Exactly. Nature hit the mute button.
It's amazing.
It is.
Just another way that snowflakes impact our experience.
It really is.
Yeah, and speaking of impact,
Okay.
we should talk about, the cultural significance.
Oh, yeah.
I mean, snowflakes are associated with, holidays?
Absolute.
Purity.
Yeah, purity and magic.
Magic, yeah.
Right.
They have a special place in so many cultures around the world.
They do?
Like that pristine white color.
Uh-huh.
People associate that with purity and innocence.
It's true.
They're often seen as symbols of new beginnings.
Yeah.
Or a fresh start.
And it's so interesting how, something so fleeting.
Can evoke such powerful feelings and symbolism.
I know, it's remarkable.
It's true. And that connection to purity, it's really strong in, Christian tradition.
Oh, yeah.
Like a white Christmas.
Yeah, white Christmas.
Right.
Yeah, the purity of the holiday season.
Yeah. And we can't forget about, paper snowflakes.
Oh.
It's such a fun activity.
Oh, it's a classic.
For the holidays, for families.
Yeah. It's a great example of how snowflakes have inspired, art
Yeah.
and cultural traditions.
And tradition.
Yeah.
It seems like we've just, scratched the surface.
Yeah, we've just barely scratched the surface.
Of the science and magic of snowflakes.
There's so much to discover.
Yeah, I know. And I think, one of the most fascinating things is that they exist at, the intersection of science and art.
Oh, yeah.
And math and even, philosophy.
It's true.
That's so cool. It's almost like each snowflake is a tiny portal to a whole universe of knowledge.
I love that they're like these little windows
I wonder what...
into these bigger ideas.
Right.
They remind us that even in the smallest things, we can find beauty, we can find complexity, we can find that sense of awe.
Okay, I know we need to wrap up soon.
Okay.
But I have one more question.
Okay, shoot.
You said before that, each snowflake is unique.
Yeah.
But is there anything that, makes them all similar?
That's a great question.
Yeah.
So, yeah, while all the little details are different, they all share one thing.
Okay.
Hexagonal symmetry.
Hexagonal.
Yeah, six-sided.
Oh, okay.
So no matter how complex those branching patterns get,
Uh-huh.
it's always based on a six-sided structure.
Why is that?
It all boils down to the water molecule.
Okay.
When water freezes, the molecules, they bond together in the hexagonal lattice.
Okay.
That's the most stable way for them to arrange themselves.
So it's just, the natural structure.
It's the natural way they want to be.
That's so interesting.
Yeah.
So even though there's all this variety, there's still this order.
Yeah, this underlying order.
Dictated by, the laws of nature.
Exactly.
The snowflake is a microcosm of the universe.
It is. It kind of is.
Yeah, it really is mind-blowing how something so small can be so complex and beautiful.
I know, right?
It's like a tiny little window into the magic of nature.
It really is, and it's that sense of magic and wonder that's drawn people to snowflakes for centuries.
Oh, yeah.
Inspiring art and music and literature.
You know, it's funny. We talk about snowflakes as being these delicate little things.
Right.
But I was reading about how their sound-absorbing properties are actually being used in architecture and design.
It's pretty cool, yeah.
That's fascinating. Architects and designers are always looking for ways to create spaces that are beautiful but also functional.
Right.
And it turns out snowflakes, with their intricate structure and all those air pockets, they have these amazing acoustic properties. So are they, like, putting actual snowflakes in buildings?
Well, not exactly. I mean, using real snow wouldn't be very practical.
Yeah, it would melt.
It would melt, yeah.
Yeah.
But what they're doing is they're studying the structure of snowflakes
Oh.
to understand how they absorb sound so well. And then they use that knowledge to develop new materials.
Oh, that's cool.
That can, like, mimic those sound dampening properties.
So they're learning from nature?
Yeah, it's like biomimicry in action.
Yeah, and applying it to the built environment.
Exactly.
That's so cool. So, like, by studying a snowflake?
Yeah.
We could make quieter spaces.
Quieter spaces, yeah, in homes, offices, even concert halls.
Wow, that's incredible.
It is pretty amazing, right?
Like this tiny little fragile thing can inspire all this innovation.
It really speaks to the power of, like, observation and learning from the natural world.
Well, this deep dive has been amazing.
Yeah, it has.
I'm never going to look at a snowflake the same way again.
Me neither.
Before we go, any last thoughts about snowflakes?
Yeah, I think, the most important takeaway here is that snowflakes are more than just frozen water.
Yeah.
They're these tiny little miracles of nature.
Yeah.
Each one unique, exquisite. They remind us that beauty can be found in the most unexpected places.
It's true.
And that even the smallest things can hold this immense wonder and complexity.
So the next time it snows?
Yeah, take a moment.
Everyone should take a moment and just appreciate the snowflakes.
The beauty.
Yeah, and remember everything we talked about today.
All the science and the history and the magic.
The magic, it's amazing.
It is.
This has been a great deep dive.
Yeah.
Thanks for joining us.
It's been fun.
Keep sending in those questions.
Yeah, keep them coming.
We'll keep on diving deep.
We'll dive deep into whatever you're curious about.
See you next time.
See ya.